So I've put off my conclusion to the A360G install and kind of my thoughts on it for a couple of weeks because I've been working on overclocking and trying to get everything dialed in. But the overclocking I think needs to be put into a separate video, not really a guide, because there's plenty of Pascal overclocking guides out there, more of my experience with getting the most out of my GPU, because I'm still working on it after about 2.5 to 3 weeks. I think I'm getting close, but I'm still working on it. So we'll touch base on overclocking towards the end, and then we'll move on to that in a separate video. So what did I replace? This is the Swiftech H240X that I took off. One of my Corsair case fans, I noticed the bearings were going out, so I put that one here and put one of my Swiftech Helix fans in its place, because they were pretty decent fans. So I think all my Corsair fans may finally be going out. Anyway, these are 140 millimeter fans, which gives you great space, but if you notice, the pump and the reservoir are blocking almost half of, well, probably a third when you look at the back end of it that's open, but a third of one of the fans. It's not touching the fins down here, it is open, but that does restrict the airflow that can go through those fins, reducing some of the cooling potential on that part of the radiator. This Apogee block, solid copper, really good block. I talked a little bit about the performance under a render in the summertime. I was peaking at about 65, 66 Celsius, so that's not bad. My goal, going back to my intro video with this, was to add the GPU to this loop, allowing me to push that one a little farther without increasing temperatures by much on the CPU. And I'm very happy to say, mission accomplished. I'm about 0 to 1.5 degrees hotter than I was with the Swiftech kit. So I'm either bang on the same or just slightly higher, which is perfect. That's right where I wanted to be. And I added the GPU. Now in Afterburner, I was able to push the GPU up to 2050 just minorly. It couldn't hold it very strong with the fan curve I had. If I took manual control, put it all the way to 100% and let it run, I could hold 2050 and sometimes get a little higher, but it wasn't cutting it that often, and it didn't last long because it thermal throttled. So typically, I left the card running at about 2036, and after maybe 20-30 minutes of playing PUBG, the main game I was playing at that time, I would see it throttle down to about 2000 megahertz. Not bad at all, nothing to laugh at. This was also with me pushing about a plus 50 to plus 62 on the memory frequency. So if I dialed that back, I probably could have gotten more. Now the GPU was running about 74 to 78 Celsius on average under a heavy gaming load. I was about 77 to 78, which is about the thermal throttle range. The card just won't go any hotter than that. Typically under a gaming load, which is the hardest load I can put on the GPU, holds steady at about 56 to 58 Celsius. I have not seen it go above 58 under normal conditions. And this room at night is, being summer in Texas, I don't run the air conditioner that much because it's expensive. So this room gets about 78 to 80 degrees Fahrenheit. So it gets pretty warm. And the card still holds that. 64 to 66 on the CPU for gaming, again, barely touching the thing. And the GPU is about 56 to 58. Last night I was again pushing the overclocks a little higher. I had 2088 going with about plus 56 on the memory. I forget what that is. It's like 5,500 and some change on the memory frequency. And both CPU and GPU were under 60 degrees Celsius consistently. So that's fantastic. Wonderful cooling. And that's a huge drop on the GPU, giving me that headroom to push the card a little farther without worrying about cooking it at all. So if you have any qualms about going aluminum to save a couple of bucks and buying this type of a kit, don't. It's a fantastic kit. I bought it myself. I did my research. I originally started by looking at a custom loop, buying all the parts separately. I just couldn't bring myself to spend that much money. I have other more important things for my money, but I wanted to add the GPU and I wanted to do some better cooling, and I enjoy building these things. I did add some 90 degrees and I did tweak a few things, which I want to talk about now. So when you saw the build video, I took my time putting the GPU together. It's been a long time since I've done a full GPU block. and I wanted to do it very well and properly. So I took my sweet time on it, and my wife was watching a movie, so I kept looking over, getting distracted by the movie. But that stretched it out, and I'm very happy with everything that I did on the GPU. Fantastic build, everything was great, I enjoyed that. When I got to assembling everything, I realized that I'm not going to be able to put my radiator the way I had planned. The fear I had of the optical drive being too close to where the tubing would come out was a problem. Now, I could have done it if I'd had two 90-degree fittings up there to send it out and down, but when I thought about moving those off of the pump reservoir, rotating that so that one could come up in, keeping one here that would come up, and then using none on the CPU, it would have made the tubing look a little goofy. Yeah, it would have worked, but I didn't like the way the tubing would have looked once it was done, because if back in the intro I said I wanted to try and mimic a kind of acrylic hard tubing look. So I didn't like that, so I switched the radiator around, put the in and out on the back side of the case, and it worked perfectly. Now, when you look at the tubing, when I did the run, there's one change that I haven't shown you yet, which I'll show you in a picture here at the end. What I did originally was I measured all of the tubing to be very close. There's very little room in the tubing for any excess give. And that allowed me to make it look kind of like acrylic tubing, just going straight up and in. It's not perfect. I know acrylic wouldn't go like the way it does, but it looks very clean, and the tubing looks more rigid than soft in a lot of areas. Out of the GPU, where I had originally planned to have one of the 90-degree fittings, I realized I didn't need that there, and what I could actually do was put a half kink in the tube. So when it's the output, it goes up and over through a slight kink to give it a little barrel roll around the input tube, and it goes up into the radiator. And that worked perfectly. The tubes don't actually touch, and the kink doesn't impede any of the tubing's openness or thickness in any way. It just allows it to twist the cable around, the tubing around, and it looks great in my opinion. The return was measured again to fit on a certain way, but I didn't want to install it that way because it wouldn't leave me a lot of room to modify any of the tubing when I needed to push it onto the barb, or when I needed to take the radiator off and move the case around to try and bleed the system. It really had no give in it. So I did a temporary solution, which was the zip tie to the top of the hard drive cage racks. Looked terrible there, but it worked. And once I got everything bled out, I moved the zip tie up to the radiator. The bottom fan mounts are just little screw holes. So I put one zip tie through that, and then the other zip tie hanging off of that. And what that does, they're black zip ties, so they blend in pretty much perfectly with everything but the part of the tubing they cross. It allows the 90-degree return fitting, so the tube comes out almost perfectly perpendicular or parallel to the top. Then it hits the zip tie at the right spot, turns, and then goes perpendicular to the radiator, almost straight down into the return on the reservoir. So it looks a lot cleaner. The way I did it in the video was just so I would have some room to mess with the tubing if I needed to modify anything or take the radiator out. I didn't want to have to undo the zip ties on the radiator to get it out to move it around. So that's why I did that, and it looks a lot better. Now I kind of knocked on it in the intro video with the acrylic side on the GPU block. I thought it was kind of dumb because you really can't see anything with the top not being acrylic, but that ended up kind of being a good thing. Because as you saw, I have a UV flashlight, and the liquid being UV responsive or UV sensitive, I was able to check for leaks very easily. And when I noticed after I first booted the system up that my CPU temps were at 75 Celsius, I knew I had a problem. I didn't know exactly what though, either bad mate on the TIM with the CPU and the block, or I had an air bubble somewhere. I wasn't sure which. I jiggled the case around. I couldn't get anything to change. But as I was looking around with the thermal flashlight, finally on the side of the CPU, from my chair looking down in the window, I could see the liquid on the side up above the return kind of doing a little flow bounce. And I realized I had an air bubble in the CPU, so I had to tip the whole case over, kind of jiggle it, and a massive bubble came out of that. Immediately the temperatures calmed down to about 67. And then I remated the CPU and got another bubble out that was buried deep inside of it. When I actually took the CPU off and really moved it around, another bubble came out of it. So I may have had a fine mate, but it took taking the whole CPU off in order to do that. So I probably should have just left the tape on the CPU or the soft backing on it, lightly screwed it down so it would be in its mate position, but not actually bolted to the core. or the heat spreader on top, and then plumbed all the tubing and done the liquid on it. That way I could have easily taken the CPU off again, moved it around to get the air out of the CPU, then properly mated the CPU. That's, in hindsight, that's what I should have done. But whatever. If your case isn't quite as big and cumbersome as mine, then it's not going to be the end of the world. The only caution I have is when you tip the case on its side, again, depending on how your tubing runs, the air out of the radiator may go back down the tubing, or out of the reservoir may go back down the tubing into your radiator, or however you've designed your loop. So, now modifications. When you saw my install, I still used the PWM splitter box from Swiftech that allows one PWM header to control many fans. So what that's doing right now is every fan in my computer plugs into that PWM header. All the intake, exhaust fans, radiator fans, and the pump all plug into that one header. And that allows the system, when certain temperatures are reached, the main fan curve in my BIOS is what ramps everything up to full power. And it works. It works well, but what I'd like to do at some point in the future is dial that in a little more. Because I'd taken so long on the install of the GPU and then refiguring all my tubing and switching the radiator around, that took a lot of time. Because you only get one shot at it without wasting your time or rushing through it, and I really didn't want to redo it. So I took my time, I made sure I planned out all the tubing runs, how everything would look, how I wanted everything, and then I did the install. Measure twice, cut once, essentially, as people say, and it's true, especially when you're doing something like this. So because of that, when I was running all the power cables and everything, I ran out of time. And because I ran out of time, I just went with the setup I had. Now I have two CPU headers that are both PWM, and I have a system PWM header. So what I will potentially do in the future is I'm going to split the pump into just CPU 1, the radiator fans into CPU 2, and then the system fans I'll run out of the system fan, and I'll just keep the breakout box. I'll just run an extension cable so it gets down to that header on my motherboard. That will allow me to have 3 separate fan curves running all of that. So the first thing to throttle up will be the pump, put more liquid through the system. Then shortly after that, I'll have the radiator fans start to go up. And then the system fans, I'll just have them ramp up probably on a linear curve straight up to 100% at a certain. On to overclocking. Now, overclocking is not something I've pushed a video card on for a long time. The last one, again, was my 8800 GTX, and that one toasted itself, being from BFG and already having a pretty hefty overclock on it. Since then, I've only done minor overclocks on my GPU. The 7970 was the last one I really pushed. My 5850 couldn't go all that high, so I didn't mess with it that much. 7970 had some legs on it, so I pushed that one pretty decently with Afterburner, but again, I kept that one on the blower style, so I was at the thermal limit fairly frequently. Now Pascal, I haven't messed with a whole lot, and just to kind of touch in, I've got some video here. The first one's going to be of the CPU and my GPU running a standard overclock that I just basically a boost on the memory, a boost on the core, and let's see what happens. Now the main thing to note here is I really hadn't pushed the power that high, so the overall core voltage percentage, I hadn't maxed that out, allowing the card to just, hey, you know what, if you need it, here's 100%, use all of the available power. And then I hadn't told it to take the power limit and adjust that limiter up to the top. The main thing that hurts overclocking on Pascal is the fact that the main default BIOS from NVIDIA locks the power at 1.93, I believe it is, 1093 millivolts. So you can't really go above that. And only briefly have I hit that wall. So with these settings that you're seeing right now, I've run into a lot of issues, and this is me playing PUBG. I've run into a lot of crashing above 2066. Last night I was able to run 2066 very rock solid for about an hour, so I pushed it to 2075, got half an hour rock solid, no drops. Pushed it to 2088 with the power, both those sliders at the max. 2088 I got about 15-20 minutes before it finally dumped. And what killed it was I came over a little hill and I had a large open field to render with trees and distance and some explosions in the distance from the red zone, and that's what finally caused the crash. And then after that I'd get maybe 5 to 10 minutes, similar stuff. So I dialed it back a little bit. I just ran a small test. I did a custom power curve this time to kind of tweak things, and I pulled back the memory overclock, just saying, you know what, memory is already pretty fast. Let's see if I yank that out, how far I can push the core. So right now I'm trying to see if I can get a stable 2100 overclock out of it. And I'm going to report real quickly before I do that separate video in a couple weeks that I played a 15-minute round of PUBG real quick at 2100. No issues. So tonight, my goal is to do kind of an hour of gameplay at 2100 and see if it actually works. 2100 is my goal on the core. If I can maintain rock solid on that, I'm going to start bumping the memory frequency up until I hit instability, and then I'll dial it back till it's stable again. So I hope you enjoyed this. If you were on the fence about these aluminum kits, don't be. You have nothing to worry about unless you mix metal. Beyond that, they are perfectly adequate and are very, very, very close, if not exactly the same as an aluminum kit. The last thing to call out is how I plan to eventually bleed and maintain the loop. If I need to dump it, you can see I really didn't do a T valve or anything that, or a quick connect fitting that would let me easily plug in a drain. I don't plan to drain this system frequently. I'm not going to mess with it. It's built, it's left alone. This guy lasted over 3 years without any maintenance, and it's barely at the minimum level on the reservoir. And it still had the same performance as it did before. The only difference was the TIM might have been a little baked, but when I took it off, it was really not that baked. It was about 50% dry. So the way I plan to drain it is I'm either going to use the pump squeeze bottle that I bought and just siphon out the liquid out of there, or I really don't have to worry about it too much. So if I burn off enough of the liquid in the reservoir, I can just hold a funnel up to it, tip the case over, and let it drain out. And then I'll be able to undo one of the tubes out of the fitting system and let it drain out that way. I'm not worried about it. It won't be the easiest thing, but again, I really shouldn't have to take the system apart much other than to top the fluid off. And the whole system used, that's where my current level is. So I filled the entire loop on half a bottle. Well, less than half a bottle, because they don't fill it all the way, so that when you go to fill the loop, it won't dribble down the side or splash out. So that's pretty good. Not much more I can say. I think it's a fantastic kit. You'd be well served by buying it, depending on how far you want to go. So thank you guys for watching. I'm going to do a separate video, as I've said a couple times in this. I tend to ramble when I don't have a script, but I tend to say my thoughts a little better when I don't have a script. But I'm going to do a separate overclocking video. It's not going to be a guide. Again, I'm just going to talk about my experience with overclocking Pascal and the performance of the A360G within that. So again, I think this is a fantastic kit for how far I'm pushing things. You wouldn't be sorry. If I'd gone with the A240, I think I still would have had pretty good performance. But I think the temps would be a little higher at the range I'm pushing. And I still plan to push my CPU to 4.4, and my GPU, if I can get it dialed in, I'm going to have it at 2100 or with the memory up a little bit as well. So thank you guys for watching, and we'll see you next time.